So here's another video, same pairs of images from the two cameras, or the same look directions I should say. Set this one playing. It's interesting things you can see at the beginning here. There's some sort of optical effect which isn't moving against the stars. So let's go back and have a look at that a second. You can just see a ring here around this object. You sometimes get that if a really bright star or a planet comes into the field of view. It just causes ghosting. It's the sort of thing that you'd expect if you were trying to take a photograph quite close to the sun and the sun's in your eyes. The light scatters down the inside of your telescope and produces all these ring patterns. But it'd be useful to know when those are occurring, and so we're asking you to tell us that too. This material is streaming from the solar wind. It's just material coming off the sun all the time. It's just material that's boiling off the surface of the sun. Very rarely does it go out of the images. What we're really interested in is clouds of material that come out, and you see them as much brighter bubbles. These things that look like Christmas baubles, well, they're bright stars and planets. This is a planet, you can tell it's moving across the background star fields, but this one in particular is moving with the star field, so it's likely to be a star. The lines on them, they're not string holding them up. That's just where the camera is saturating and the light is bleeding across pixels. But there was an event back there. I'm just going to pause the video and go back and show you that part again. This is the sort of storm we're after. I think perhaps I'll go back a little bit further too. Play that again. You see a sudden brightening here and a big bubble of material come out as it heads across the camera. Now I didn't see that mirrored in the other camera, so let's go back and have another look. You see it come out of that one, that big bright bubble there, but at the same time, does anything happen on the behind spacecraft? And I can't see anything. There's no reason they should be in both spacecraft at the same time. That all depends on what direction they're moving in. There's something that might be very faintly going off there just beforehand, so maybe those two are associated. That one occurs just before the one in A. Doesn't matter if you claim that you can see both or just see one. It's all useful information to us. So for this occasion, I'm going to say I just see it in the ahead spacecraft. And I'm now going to wind the video until it reaches the blue line. Go backwards and forwards just to be sure. I think it's that faint front there. Don't let your eyes be distracted by the brighter stuff on this side. The material will fade as it moves across the field of view because it's expanding into space and it's getting fainter because there's less material there to see. But I think that's roughly when it's going to reach the blue line. About there. So I'm going to say that it's halfway now. Go on to the next stage. And now we want to know where it comes into the field of view. We need to know two positions so we can work out its velocity. So let's wind that back. And where does that extra bright feature first come in? We see the streaks there, but they're just the normal solar wind streaks. But here comes something, that's the bright thing I'm after. So let's wind that back. I think it comes in about there. So I'll say it starts now, and I'll send the answers. Now, that gives us an estimate of about 313 kilometers a second. That's still very fast. The more information we can get about these storms, the more accurately we can determine how fast they're going and what direction they're going in.